Welcome to qnawire.
So now we have problems where we're supposed to use some software to look at do some parameter studies. Where obviously you could do this by hand. It would take it would take a long time. Well, unless you did, it only took a few points. But what we're wanting to do in this problem 8 from 108 is we want to look at the boiler pressure, the effect of the boiler pressure on different properties in an ideal Rankine cycle. So in this cycle, I guess I did it over here. Here's our cycle here. And so our boiler pressure is here. So we want to, how does it change as we change the boiler pressure? How does the efficiency and various things change? Um, and so I just basically spit out all kinds of different, what I thought might be possibly interesting numbers. So we went from a boiler pressure of 500 kilopascals, so pretty darn low, all the way up to 220 megapascals. Um, so I got the efficiency for each case. I got the net work out, or the net specific work out, and this is in joules per kilogram, not kilojoules. I also looked at the quality factor at 4 here to make sure see if we were in the two phase or not. And in this case, for all of these, we are in two phase. Um, I don't know why, but I repeated the pressure at 3 here. Heat transfer in specific heat transfer in joules per kilogram, specific heat transfer out in joules per kilogram, work into the pump in joules per kilogram, specific work, and then work out of the specific work out of the turbine in joules per kilogram. So one thing is obviously clear is that the work that specific work we put into the pump goes up a lot because we got to pump it up to a higher and higher pressure. But if you look at this compared to this, it's pretty minuscule. So the fact that this goes up is almost irrelevant. You could almost basically say that that's zero because it contributes almost nothing to the net here. If you look at these net values here, I'm thinking that that might be actually let me look at my calculations here. Um, I'm thinking that that may be, this might be in kilojoules. Let me just make sure if I change the units on there or not. And let's see, problem 108. Let's see here. The net, the pump in, did I, specific work of the pump in? Oh, I did. Yeah, I did. I did convert that. I was going to say this took way too small. Okay, so that's could be kilojoules. Anyway, you can see here that, it's just to the third decimal place that it changes, the pump, between the pump, their specific work into the pump, cut off of the work out of the turbine. So, all right, so obviously here's just all these numbers. So obviously it's nice to make some plots out of these things. But we can generally see efficiency is going up. Net work is going up. Well, kinda. Not. It kind of started to drop here. Again, the quality factor is going down, which we did expect. Heat transfer in is generally going down. Heat transfer out is generally also going down. Again, we talked about that, and the power, the specific work out of the turbine is going up to a point, right? And so if we look at these, values here, so we have the net work out of the here. So we can see that it's basically very flat, through this region. And you can see we actually have a maximum right around here, but it's very flat. So it goes up quite a bit, but then it gets very flat. And we actually do have a maximum, which I think, what did I say? What did I look at? It was right about here. So about 15 megapascals. So around in here, there's a maximum. But again, once we get past, past 10, it's not very, it doesn't change much at all. And then, getting somewhere out here, 20 megapascals is, you got to worry about leaks and a lot of other things at these high pressures. Now, the efficiencies continue to go up, right? Again, we kind of get, less, return on increasing it. So, we get some slight rise in efficiencies after like 10 megapascals, but not nearly as much. We don't want to be operating a boiler pressure down here at, below 1 megapascal. It just doesn't make any sense. We can see here that the quality factor does indeed stay below 1. And then here's the cycle, right? And this is the cycle where we got this. So if we had a different pressure, we'd wind up at a same temperature. We'd wind up out here. So that's why our quality factor goes up. Oh, sorry, it goes up as our pressure goes down. So if we were like down here at some ridiculously low pressure here, right? We'd wind up here, and then we'd have to wind up. We'd wind up like out here, and then coming down here, and we'd be, in this saturation right inside here. So that's why it kind of goes to 1, because we wind up being way out here in high entropy levels at these low, at the low pressure, but at up here at the same temperature. All right, so I think there's not much else to say about that. Yeah. Anyway, the only interesting thing here that I can say is really that you can see that max power does not occur when there's max efficiency. And that's generally true in a lot of systems. And you look at that like in DC motors, where do you get the maximum efficiency of the motor and where do you get the maximum power out of the motor? Not the same point. You might think that they were because, well, if it's more efficient, there's more, it's going to convert more. But that's not how things generally work. So efficiency and the power out is different because the power in changes as you change things too.